Okay, so let's assume that we have a sphere for which we have calculated the surface area of the sphere with uncertainty. So the area says 25 plus or minus 0.7 meters squared. And from this, we want to find the volume of the sphere with uncertainty as well. Well, again, the uncertainty in the area is a small change in A, which is of course delta A. And as here now A is the independent variable, delta A is the same as dA. Well, since we want to find the volume of the sphere, we need to connect the volume of the sphere with its surface area. That is not a very natural connection, right? Both the surface area and the volume of a sphere are simply connected by the radius of the sphere. So let's write down both of these relations. So the area of a sphere of radius r is equal to 4 pi r squared, and the volume of a sphere of radius r is equal to 4/3 pi r cubed. So we have both a and v as functions of the radius of the sphere, but we need to find v as a function of a. Well, what we can do is in the first relation, let's isolate r in terms of a, and then we'll substitute back this into the relation with v and r to obtain a relation between v and a. So if you isolate r squared, then you get a over 4 pi. Take the square root as r is positive. You obtain the root of a over 4 pi. And you can write this, of course, as a power of a half. So a over 4 pi to the power of 1/2. And now we have r as a function of the surface area of the sphere. We can now replace in the relation for the volume. So the volume will become 4/3 pi times the radius cubed. Well, if you cube this expression, you will multiply a half and 3, so you'll get here a power of 3/2. So a over 4 pi to the power 3 over 2. And before doing anything else, let's simplify this if we can. So we have 4 pi over 3. And now let's break up a and 4 pi. So we have a to the power 3 over 2 over 4 pi to the power of 3 over 2. And if you notice, we have a common multiple of 4 pi top and bottom. The power on top is 1. The power here is 3/2. So 3/2 minus 1 is 1/2. And so we are left on the numerator with a to the 3 over 2 over 3 times a power of 1/2 of 4 pi, which we can also write as the square root of 4 pi. And let's do one more simplification. So root of 4 is 2 times 3 is 6. So we have as a constant multiple 1 over 6 root of pi, then times the power of a. And now we have expressed the volume of the sphere as a simplified function of the surface area of the sphere, and so now we're good to go. So if we evaluate, if we now replace the value of a of 25 in the expression, and the volume becomes 25 to the power of 3 over 2 over 6 root of pi. We can simplify here. The root of 25 is 5. 5 cubed is 125. So we have 125 over 6 root of pi. And if we now use a calculator to estimate this, we get approximately 11.754 meters cubed. So we now have a value for the volume of the sphere. We now want to find the uncertainty of this measurement. Well, the uncertainty in the volume, of course, will be a small change in the volume. we approximate delta v by the differential dv, which of course is the derivative of the function with respect to the independent variable, which is a, times of course the change in the independent variable, dA. And of course dA and dA cancel, and we get dV. Well, we have to differentiate now the volume in terms of A. So the volume is this in terms of A, so the derivative now, 1 over 6 root of pi stays as a constant multiple. And the derivative of a to the 3/2 from the power rule, bring down the exponent, subtract 1, 3/2 minus 1, 1/2. So we now have our derivative, dv over dA times, of course, dA. We can simplify this a little bit. 3 cancels with a 3 here, and we're left with 2 times 2, 4. So we have the root of 8 over 4 root of pi, and of course times dA. And now we have all of the required quantities, so we can replace. So what do we get? Well, the root of a is the root of 25 over 4 root of pi times dA, which is 0.7. We can simplify a little bit. Root of 25 is 5. 5 times 7 is 35 over 10, 3.5. So we have 3.5 over 4 root of pi. And if we evaluate this now with the calculator, we will obtain approximately 0.494 meters cubed. And we can now write down our conclusion. So the surface area of the sphere was 25 plus or minus 0.7 meters squared. And now the volume of the sphere with uncertainty is 11.754 plus or minus 0.494 meters cubed. And that's it.